What we're doing here is at if I'm looking at my sign values, my ordered pairs, at 0, the y value is 0. Everybody agree? At pi over 2, what's the value of sine? Okay. So at pi over 2, the value of y is 1. At pi, what's the value of y? 0. 3 pi over 2. It's negative 1. And then at 2 pi, it's back to 0. What happens here is that you'll notice that this goes into one full revolution. It goes between 0 and 2 pi. If you notice something else, let me move this off for a second. I'm going to show you something nice little trick. Going from 0 to 2 pi, that's the amount of time it takes to make one full revolution on the circle. They call that the period. How long does it take to go around something? Okay. The period is broken into a couple of different spots. You'll notice that there's a halfway point at pi. There's a halfway spot between 0 and pi. And there's another halfway spot between 0 and 2 pi. See how that nicely fits into your quadrantals? And that's what's going on. What happens here is when we find this, what's called the period, and I'll show you guys how this all works out, because not every one of them is just always y equals sine of x. What happens here is once you plot out what's called your period, you break it into these 3 other spots. The halfway point, the quarter point, and the 3/4 point. And that's what these things wind up giving you. You'll notice that your y values only fluctuate between 0 and 1, and then, negative 1 and 1. Because your radius was never, bless you, your sine value was never greater than 1. Your sine value wasn't smaller than negative 1. How high something goes up or something goes down is called the amplitude. So the amplitude of this would be called 1. And like I said earlier, what happens here is that you just wind up plotting these simple 5 points. And there's your curve. That's a sine curve. Starts at 0, raises up to the amplitude, goes back to 0, goes down to the opposite of the amplitude, and goes back up to 0. So depending upon what your amplitude is and what your period might be, the sine curve can be stretched. It can be lengthened to go higher up, lower down. It can be compressed. It's all dependent upon those quick little values of A and B. It also works the same way with cosine. If you look at the cosine values of your unit circle are your x coordinates. Starting at 0, it's 1. Pi over 2, it's 0. At pi, it's negative 1. 3 pi over 2, it's 0. And back to 2 pi, it's at 1. So what's different about the cosine curve is that it starts at its amplitude, works its way down, and comes back up. Whereas the sine value starts at 0. It does that. So what we're doing here today, guys, is we're going to look at some very simple tables. 0, y is 1, pi over 2 is 0. And hopefully, even with your tables that you were working through with the unit circle, you would have seen that nice little way that was working out. Again, I'm not too worried about. I know I gave you guys that funky trig graph paper. We'll probably never use that. I just wanted to have something out for you guys to see because you haven't seen it before. You'll be creating it on your own. It's very, very simple. Again, the period it takes to go all the way around the unit circle is 2 pi. One full revolution, one time around. 2 pi out at the end. 0 there. What's halfway between 0 and 2 pi? pi. What's halfway between 0 and pi? Half pi. And then halfway between these two guys becomes 3 pi over 2. Again, yeah.
Are we going to only have those 5?
Yeah. Yep. What'll happen when we do the shift, so then we might have to create some more, but it's not bad. And so far, our period's been pretty easy to work with. Some of the periods can get kind of messy, but it's just fractions. Oh yeah, there's a lot of fractions in this. Start at 1, work your way around. Like I said, cosine will always start at your amplitude, go to the opposite of the amplitude, and go back up, or go back to the regular amplitude. Okay. Not so scary either. Let's talk about the fun stuff now. Because not everything is always this clean. You have all this junk to worry about, which basically is this. The most important thing about all this stuff here is that for the two functions we're going to be looking at, y equals a sine of bx and y equals a cosine of bx, this amplitude is always the absolute value of the a, and the period will always be defined as 2 pi divided by the absolute value of b. Remember, your amplitude is how high up and how low it goes. The period is how long it takes to make one full revolution. Your amplitude into the absolute values. Okay? So like I said, what we're going to wind up with here is we're going to identify some A's and B's. Tomorrow we'll do A, B's, H's, and K's, because that all comes back with this as well. And then I'll identify horizontal and vertical shifts off of these. Today we're just worrying about the amplitude and the period. And I apologize, I'm still kind of out of it after this weekend. It's just we're all in my house. Yeah, this is fun. Yeah. All right, let me show you some examples. Oops. We'll start with something easy. Y equals 2 sine of x. Yes, sir.
We need to put our name on the fridge.
Oh, yes, that's right. I have to find post-it notes. No, I told him he had to remind me because I forgot about it. Oh, right in the hand. Bless you. I don't know what, you'd have to add those two scores. What was it, 60 points? So that'd be what? 48 combined?
What do you have to add?
It'd be, we'll see it would be, it's a tough test. So it'd be 0.8 times 6 is 48. And so 48 or higher if you add them together. Excuse me. So if I'm looking at y equals 2 sine of x, again, what I'm going to do here is identify what my a and my b is. Here, what is my a value? 2. What's my b value? 1. That means my amplitude is going to be the absolute value of a. What's the absolute value of 2? 2. The period is going to be 2 pi divided by the absolute value of 1, which is 2 pi. We'll worry about these intercepts, these maximums, and the minimums here in a second. All right? So when we get this far, we've identified our amplitude and our period. That's what you always want to do first. You always want to get that. Now you're going to draw out your period. Our period is 2 pi. So what's the last number I put at the end of that x-axis? 2 pi. This is starting at 0, so I put a 0 here. And now comes the fun stuff. What's half of 2 pi? What's halfway between 0 and pi? What's halfway between pi and 2 pi? Even though this is the same generic scenario of the ones we just did, those are the same questions that I'm going to ask you guys over and over again, no matter what your period winds up being, because it's the easiest way to set them up. Okay. What is your amplitude? 2. So I just have to mark off 2 spots now on the y-axis. So here's what happens. Sine always starts at 0, 0 for its parent function, no matter what the period and the amplitude is. It will always start at 0, 0. So the first point that you're going to plot is 0, 0. Now start thinking about what it did on the unit circle. When when sine got to pi over 2, it reached its maximum value, didn't it? Now, that was when your amplitude was 1. What's your maximum value going to wind up being now? 2. So here's what happens. Sine starts at 0, goes to the amplitude, back to 0, the opposite of the amplitude, back to 0. Sine will always follow that pattern. 0, amplitude, 0, opposite amplitude, 0. Okay? And there's your curve. What are your intercepts? Yeah, your x-intercepts are at 0, pi, and 2 pi. On a non-shifted one, yes. But remember, it depends upon the period. If the period was different, then the intercepts would be different. When the period is 2 pi, yes. Bless you. The maximum value here is what? 2. And the minimum is? -2. Okay. Again, all we're looking at here is just trying to identify some maximums and some minimums without too much of a hassle. Again, hopefully not so frighteningly scary. Okay. I know it's Monday. Just what you guys wanted to do. Okay, let's try a different one. 1/2 sine x. What's going to change now? What is it? The only thing that changes is the amplitude. Instead of going to 1, what does this one go to? Half. So your amplitude is your A value. Your A value is 1/2. Again, it's positive, so I don't have to worry about my absolute value. My B value, again, is 1. So that means my periods can be set to 2 pi. I think my next one has the shift, or a different period on it, so we'll look at that. Again, walk out your period, cut it in half, cut it in half again, cut that part in half. Oops. And now it's just a matter of going to your sine set. 0 to A to 0, opposite A to 0. Intercepts in this case, again, not bad. 0, pi, and 2 pi. If I wanted to get funky here, I could ask you for the ordered pairs for all 5 of those, right? 0, 0, pi over 2 and half, pi and 0, 3 pi over 2, -half, 2 pi and 0. Not bad. We actually use the ordered pairs a lot when we do the shifts. It's much easier to use some of those. What's your maximum value here? And your minimum? Let's find something more difficult. Okay. Cosine of 2x. Again, what we always start with is identifying our A and B. Excuse me. In this case here, my A value is what? My A value is 1. My B value is 2. So now that means I'm going to have some moving around from what we did last time. Our amplitude is going to be what? 1. Our amplitude is still equal to 1. Our period is going to be different. Our period is going to be 2 pi now divided by 2, which is pi. So now, instead of working with 2 pi on the x-axis, my far spot is going to be pi. Let's make this a little bigger. What's halfway between 0 and pi? Good. What's halfway between 0 and pi over 2? Pi over 4. And what's halfway between pi over 2 and pi? 3 pi over 4. Do you see how you change those values just by using halvesies? That's really all it is. We do lots of halvesies in this chapter. Your amplitude is at 1, so we start at. Cosine is different. Remember, it always starts at the A value, so cosine starts at 1, goes to 0, goes to the opposite, back to 0, and back to A. There's your curve. Even though that your period is truncated, it's half of what we've been working with, that 2 pi, do I have to draw it that it's that much narrower? No. You're just labeling it out correctly. As long as you label it out, the scale of it doesn't really matter. Okay? You're just looking for a visual representation of those values. So now in this case, what are my intercepts? What are my x-intercepts? Oh, when we're talking intercepts, we're usually talking about the x. It's just one. We usually just look at those. But yeah, I see what you're saying though. So that would be pi over 4 and 3 pi over 4. What's the maximum value? What's the minimum value? Your max and mins are going to be your plus or minus of your A value. Okay. Let's put one of them together that has both. Excuse me. Thank you. It is. I tried my best to draw this or write it out. It doesn't work. So this is 1/3 cosine of pi times x. Let's make this weird. 1/3 cosine of pi times x. What's your A value?
1/3.
What's your B value? Okay. So my A value is 1/3. My B value is pi. Therefore, what is my amplitude? 1/3. Good. My amplitude is 1/3. My period is going to be 2 pi divided by B. What's 2 pi divided by pi? 2. Is that okay to have 2 as the period? Absolutely. Yeah. All it's doing is just saying it's just a different, it's a weird B value. All you're doing is you're taking these values and multiplying them by pi as you're going around. That's all. So when I go to plot this, again, all I'm doing is plotting out on my x value where my period ends. I know it starts at 0 and get my halfways. Oops. I'm so used to writing it as pi. Are we okay with that? What's the highest value this is going to wind up being? 1/3. What's the lowest value? Okay. So can I just say it's about here at 1/3? Does it have to be perfect? No. I'm just plotting where it looks like it could be. Where does cosine start? Does it start at 0 or your A value? A value. So you start at your A. Go through your cycle. There's one period of cosine with a funky A and a funky B. Not to be confused with a funky B.
He's back. He's back.
Yeah, he's back.
I'm miserable today. Yeah, I'm miserable today. Okay.
Okay, I'm pretty tired.
Not so scary, is it? Can't wait to do shifts with you guys. You'll be really mad at me. Too easy.
So you're saying class even though the rules are not.
Oh, wrong one.
Yeah, but I think it's counts the times. There's a lot of math.
All right. Graph those two. You guys are doing all right. Let's see. 3 cosine pi x. Y equals 3 cosine pi of x. It means my A value is 3. My B value is pi. So my amplitude is 3. My period is 2. Second, I didn't know if I was doing cosine or not. Did it look like that? All right. The other one is the funky, you gotta watch your fractions here. Y equals 5 sine of 3 pi of x. My amplitude, my A value is 5. My B value is 3 pi. So when I go through all of that, that means my amplitude is 5. The B value, your period, is 2 pi divided by 3 pi. You get 2/3. And this is where a lot of people are going to run into problems when they're working with their fractions. I know I'm out here at 2/3. What's half of 2/3?
1/3.
1/3. What's halfway between 0 and 1/3? 6. Now, but you can start to see how you could get some really weird ones in here. The weirdest one when you start mapping out these things is tangent. Tangent gets some funky fractions pretty quick. And then what's between 1/3 and 2/3? Again, once you start working through them and you get your commons out, you just have to simplify your fractions. Amplitude is 5, so I kind of say it's here and here. It's a sine function, starts at 0, goes to a, 0, opposite a, and 0. Let me ask you this. What if your a value is negative? What would it do?
It's an absolute value, so.
If, let's say this a value was negative 5. Does your amplitude change?
No.
What changes in your graph though?
Start from.
It goes down.
It goes down first, then comes back up. Okay?
That makes sense.
Let me show you one. Let me show you one. I don't know if they don't normally do a lot of negatives in this first round. Let's make this negative 2 sine of 1/2 x. Just so you guys, because you will see a lot of negative values going into tomorrow. So I figured might as well do a couple if you have time.
Can you show us a shift?
Tomorrow. We'll do all the shifts tomorrow. It's too much work. It's too much for one day to do the 2 graphs and a shift because there's a lot going on with the shift. Let's say it's y equals negative 2 sine of 1/2 x. Again, this means my a value is negative 2. My amplitude is still 2 because it's the absolute value. My period, my b value is 1/2, so my period is going to be 2 pi divided by 1/2, which is 4 pi. Good. Lots of people get that wrong. When your b value is fractional, it means you multiply by its reciprocal. Okay. A lot of people get that wrong. Yeah, but if I'm taking 2 pi divided by 1/2, the same thing as 2 pi times 2. That's what I mean. If you have a fractional b value, just multiply by its reciprocal right away. So now I know that my amplitude is 2, my period is 4 pi, so here's 4 pi. Boy, we should get these others correct. Sine always starts at 0, goes to its a value, back to 0, opposite a value. So in this case, instead of going up, it goes down. Okay? That's the only difference when your a value is negative. It goes the opposite direction to start with. Same thing with cosine. If the cosine value had a negative for an a value, it said, yes, it starts in the negative, works its way up, and comes back down. I didn't think it would be that big of an issue for you guys to see that, but I figured I'd show you. I don't remember if there's any, I honestly don't think there's any today that has that. But this is kind of the groundwork of all the shift stuff. So, let's do a couple of these for tonight. Excuse me. Let's see. In these 2 sections, let's see. We did not do anything with tangent, so I want you guys to do on, I forgot what page this is. This is page 836. 836. I'd like you to graph whichever ones that don't say tangent for right now.
All non-tangent.
Yeah, let's start at 36. Don't worry about these.
So 36.
So it'll be 36, 38, 39, 41, and 43. We'll graph those. And then these setups here, 36, 38, 39, 41, and 43. And then 44 through 49. The 44 through 49 portion is you're writing the equation, given the amplitude and the period, just for sine. You don't have to worry about cosine or tangent or anything like that. You'll find that it's going to be relatively easy. Remember, amplitude is your what value? Period is your? Will be, it's 2 pi over b. Yes. Just remember that the period here, the period equals 2 pi over the absolute value of b. So you have to work backwards on a quick little equation there. Okay? Does that make sense? So you got 5 graphs and 6 equations. We'll shift it tomorrow. It's good times. Yeah, go ahead.